For a two group grading, just like given in figure 5.4, we have one unique solution, and we get that solution from two equations. First of all, for availability, which is K, and it would be equal to S plus C. This is the total number of columns in this case: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. While these 1, 2, 3, 4, 5, 6 columns are for singles and 4 columns are for commons. So that's why we have written this equation as K is equal to S for singles column plus C for commons column. Similarly, if we try to deduce an equation for the number of trunks, that would be equal to 2 times the singles columns plus the number of commons column. For example, in this case, the number of singles columns is 6. We multiply it with 2, we get 12 plus 1, 2, 3, 4. 4 columns for commons. The 12 plus 4 would be 16. So the total number of trunks here would be 16. From these two equations, if we subtract this equation for trunks, n is equal to S minus C, if we subtract the first equation, which is K is equal to S plus C, so we get n minus K and 2S plus C minus S plus C. C and C would cancel out, and 2S minus S would give us S. So S is equal to n minus K, and so C would be equal to 2K. From these two equations, C would be equal to 2K minus n. But that would be a simpler case if we have two groups. But if we increase the number of groups from 2 to 4, just like in the case shown in figure 5.5, what would happen is that the number of solutions would not be unique, or they would not be single. There would not be a single solution. There would be many solutions possible. Now we will see how many solutions are there and which solution we should select as the best solution. First of all, we will see out of these 4 groups, we will see what are the factors of these this number. For example, we have 4 groups just like this: 1, 2, 3, and 4. There are 3 factors of 4, that is 1, 2, and 4. So there would be 3 factors. We call them F1, F2, and F3. The total number of how many these are taken together. For example, how many columns are singles, how many columns are doubles, or how many columns are quadruples. That is given by the value R. So if we add them up, we get the value K, which is the availability. We are just extending the case of 2 groups that we have already discussed earlier in this case, and that was our basic figure for that. Here we had 2 groups. We are just extending it to 4 groups. Here what we have done, you can see 3 different examples of using these 4 groups. We can have 1 column as individual, 1, 2, 3, 4, 5, 6, 7 columns as partial commons, and 2 columns of full commons. So similarly, what would be the total number of trunks in this case? Just like we found out that the total number of trunks in a 2 group case was 2s plus c. If we have 4 groups, then it is not an exact value. It is not a unique solution. What we have is sigma I is equal to 1 to q r1 ri g over fi. That would be equal to n. And in this way, we can have values of n and k. Now we find the value of the differences, the sum of the differences, of the successive differences of these values, and the case with the least value would be selected as the best possible trunking system. This can be explained quite easily using an example. This is the example 5.1. Here we have to design a grading system for 20 trunks to switches having 10 outlets. So 10 outlets means there are 10